Introduction to probability. Introduction to probability. So probability has very many definitions. You can say probability, the proportional frequency of occasions on which some stated event occurs. Proportional frequency. Like if you believe that something is going to happen, there are 60% chance of something happening, that would be the probability. And if you talk about probability in terms of events, then we can clearly say if an event can happen in A ways and fail in B ways, all possible ways being equally likely, then the probability of its occurring would be A plus B, and its failing would be B over A plus B. So that means that A plus B becomes the sample what? Becomes the sample space. So if you believe that the event can happen in A ways, fail in B ways, then you can easily express the probability of its occurrence as A plus this one here, A over the sample space, which is the total. Okay. And then you can get the probability of its failure as BA over B. Thus, we say probability is a number. It's a number, it's a ratio, it's a fraction. You can express probability as a ratio, as a fraction, but you cannot exceed 1 because the total, because of being a ratio or a fraction, total probability is equal to 1. Probability cannot exceed 1 because it is a fraction. So as we talk about probability, it becomes important that we also understand events and their outcomes. Events, we are looking at occurrence or an activity, which you expect that if something occurs, there's going to be an outcome. Like if you toss a coin, you can get heads uppermost or tails uppermost. If you throw a die, you can get, a face with a 1 or 2 or whatever. So those are events. And talking about events, we have 4 major types of events. We have what we call mutually exclusive events. We have independent events. We have conditional events and exhaustive events. So you see that all our probability will be rotating around these events. So if you're to talk about mutually exclusive events, 2 events A and B are said to be mutually exclusive if the occurrence of event A outrightly affects the occurrence of event B. In other words, if A occurs, it excludes B from occurring. If A occurs, it excludes B from occurring. And because of that, we say that the 2 events don't have an intersection. The intersection of event A and B, mutually exclusive, is an empty. They will never happen at the same time. For example, you can give an example of coin. If you toss a coin, you can either get heads uppermost or tails uppermost. They will never appear at the same time. So if occurrence of heads is A and the occurrence of tails is B, then outrightly A and B are mutually exclusive. If tails show, they exclude heads from showing. And the reverse is also true. So our very first equation this evening is this one here, which you can take note. the probability of A intersection B is an empty set. Then number 2, we have independent events. These ones here, they don't affect each other. 2 events A and B are said to be independent if the occurrence of event A does not affect the occurrence of event B. So it means that the 2 events can actually happen at the same time. The 2 events can happen at the same time. And because of that, from probability theorem, the probability of A intersection B, if they are independent, is going to be the product of their individual probabilities. Okay, for independent events, probability of A intersection B, you simply multiply the 2 individual probabilities. So these ones you're going to find in the notes. You download the notes, you don't need to write here. Then we have conditional events. 2 events are said to be conditional if event A and B are said to be conditional if B occurs, given that A has already. B can only occur if A has already occurred. So we denote that as probability of A given what? Probability of A given, probability of B stroke A, which reads probability of B occurs given that A has already occurred. So if we try to put it in an expression, our other equation this evening is this one here. The probability of A given, probability of B given A is equal to probability of A intersection B over probability of A. So that's number 3, which reads probability of B given what? Given A. So again, you'll find this equation in the slides when you download those slides. Then we have exhaustive events. 2 events and B are said to be exhaustive if when you add the 2 events, you get the total probability, which is 1. So in those circumstances, those events are said to be exhaustive events. So that is the probability theorem. So we are going to look at the distributions. Okay. We are going to look at probability distributions, which are key to our discussion. So a probability distribution is just a set of things. And of course, like this class here, this could be a distribution of accountants. You can collect information about us on age, race, income. You can talk about the weight and all that. So you find that probability comes with a probability distributions, or the distributions are basically helping us in understanding a collection of things. So to start with the word distribution, a distribution is a set of things like I have mentioned. It could be a set of students in a class. We can look at the marks scored by the different students in a class, and that will be the distribution of marks. So highly examinable on this course are the types of distributions. So we are going to discuss 4 major types of distributions. We shall discuss the discrete distributions, binomial distributions, Poisson distributions, and the normal distributions. In terms of sizes, discrete distributions are those where the size is less or equal to 30. And then for normal, if you're talking about size, normal distributions are those where the size of the distribution is greater than 30. So we shall begin our discussion this evening with the discrete distributions. And of course, we begin by looking at this activity, December 2011, question 1B, where we are given a probability distribution of a random variable X described by this formula. Okay. And you can see the values that X can take on are 1, 2, 3, 4, and 5. Now, if we are looking at probability distributions, the first thing that you might be examined is the distribution itself, writing out the entire distribution. So the examiner may say, write the probability distribution of X. Write the probability distribution of X. But before we go there, I'm going to give you some 3 minutes, 5 minutes to take a screenshot or to write the question down in your books. And the topic we are focusing on right now are the discrete distributions. So let me know in the chat when you're done with this question so that we write out the probability distribution of X. We were required to determine the probability distribution of X. So everywhere you have the X from the expression, you simply put the value. So I want confirmations that indeed, when you add 1 over 15 plus 2 over 15 plus 3 over 15 plus 4 over 15 plus 5 over 15, you get a 1. This is the total probability. Total probability. Do we get a 1? Has anybody tried to see that we get 1? Okay. So we are getting a 1 there. Thank you. Next, we were required to compute probability that X, probability in our Roman 2, probability that X is greater or equal to 3. Yeah, greater or equal to 3. So where do we see X greater than 3? So that is at 3 itself, because 3 is inclusive. And then the 4 is greater than 3. And then 5 is greater than 3. So that's going to be 3 out of 15 plus 4 out of 15 plus 5 out of 15. So that brings us to about how much? That brings us to about how much? That is 12 out of 15, correct? Which we can still reduce as 4 over 8, or what some people want, 0.8. So that is how simple discrete is. Then in this third part of the question, we are required to compute the mean of a discrete. Now the mean of a discrete is also known as the expectation and is expressed as EX. The mean is our next calculation. Someone is saying they didn't get that. What did you get, Martha? What did you get? Did you get 12 out of 15? Because we're just adding 3 out of 15 plus 4 out of 15 plus 5 out of 15. The computation is just about adding, because probability of X, where is X? Where do we see X greater than 3 on this distribution? X is greater than 3 because they're saying greater equal to. Greater equal to means that 3 is also inclusive. The 3 is there, the 4 is there, the 5 is there. So I add 3 out of 15, 4 out of 15, 5. You just add, okay? You simply add. All right. We are talking about the mean. The mean of a discrete is known as the expectation, which is given as x times the probability, xp. Okay? The mean of a discrete is known as the expectation, denoted as ex, and we get it by multiplying the probability and the x value. So expanding the table that we have, we shall include another row where we multiply the x and the probability. So for that case, we shall be multiplying 1 times 1 over 15, which gives us 1 over 15. 2 times 2 over 15, which gives us 4 over 15. 3 times 3 out of 15. I'm basically multiplying the x value and the numerator, because everywhere it remains 15, 15. Okay? So 3 times 3, that's a 9. 4 times 4 up here, that's a 16. 5 and 5, that's a 25. So when you add all these figures, we end up with 55 out of 15. And that is the expectation or the mean of x. Or if they don't use that, they'll talk about expectation of x. So I'll give you half of a minute to put down this. Next is the the variance of a discrete. The variance of a discrete is denoted as VARX and is given by that very nice formula here. A very nice formula right here. Now in this formula, we need to get the x squared. This part here, we need the x squared, which we shall multiply with the probability. And then this is the mean squared, which we have already calculated. So it means that here, what is missing is this part, because this one we already have 55 out of 15, which we shall simply square. So you'll need to add another row. But before we go there, kindly put this one down in your books, because that's what you're going to use in the solution. So we add a column where we square the x. So I'm going to work with let me see, let me work with Faith. Faith, unmute. We do this together. Faith. Are you there?
Yes, yes, I am.
Let's square the x. The first one will be 1 squared.
Are we going to put it in fraction or decimal?
We are squaring the x first.
Okay. 1 squared is 1.
Uh-huh.
Then 15 squared
No, no,
is
no, no, no.
200.
2. 2 squared. We are squaring the
Oh,
x first.
oh, okay. 2 squared is 4.
Mm-hmm.
Then 3 squared is 9.
Mm-hmm.
4 squared is 16.
Perfect.
5 squared is 25.
Good. So now we are going to multiply the square and the probability. 1 times 1 over 15.
Is 1 over 15.
4 and 2 over 15.
Is 8 over 15.
9 and 3 over 15.
27 over 15.
16 times 4 over 15.
64 over 15.
25 times 5 over 15.
Is 125 over 15.
Did you use your head there?
Yes.
Good. You're very sharp. So now let
Thank
us
you.
add. Can you use your head to add this one? 1 over 15
No.
plus 8 over 15 plus 27 over 15.
That is 9, then 36 plus 64. That is 100. Right? 36 plus 64. Sorry, forward. Yeah, it's 100 over 15. Then that is 225 over 15.
Good. Wow. Thank you so much, Faith.
You're welcome.
5 out of 15. So friends, I think Faith has nailed it. The squares, she has them right. And then after that, we are multiplying the squares with the probabilities. So let us take off a few minutes. I think 2 minutes are enough. Put this in our books. Then you can give me the variance. Why not? Just substitute in the equation and give me the variance. Can we continue? Yes, yes. Okay, so we are done with the variance. Now, the calculation. Is this okay? Because from the formula, we have variance is equal to summation x squared probability of x minus ex squared. So this is what we have here. This is the expectation. So that should be able to give us a variance of 1.56. 350 out of 225, which is 1.56. Okay. Standard deviation. The standard deviation, we would simply get the square root of the variance, quite easy. Square root of 1.56. What do we get? We had 1.56 from this one here. So if you get the square root of 1.56, what do you get? Okay, I'm told it's 1.25, which I think is correct. 1.25. Okay. All right. It's your turn now. November 2013. Using the same knowledge of discrete, talk to me about this one here. The table below shows a variable and probability of occurrence. Now, this one is a discrete. This one is a discrete. After looking at all the other distributions, you will appreciate that this is a discrete. Now, the first concept we are going to use is that the total probability of a discrete should be giving us 1. So if we make this one x, the question is, what is the missing probability? Oh, let me call it y, because now they are calling it x as well. You're talking about xx, there will be too many x's. Let me call this one y, the missing figure. So it means that 0.2 plus 0.1 plus 0.3 plus y plus 0.2 is equal to total probability, which is 1. That is one of the properties of a discrete. So the question is, what is y? What is y? Let's do that one quickly. In the next 3 minutes or 5 minutes. So someone here is saying y is 0.2. Y is 0.2. Okay, another person has agreed to that. Looks like y indeed is 0.2. Our y must be 0.2. Y must be 0.2. I just need one more person to confirm. Yes, 0.2, JB. Fred, 0.2. Maureen, Kokasi, Majib, 0.2. Martha, 0.2. Some more team says yes, 0.2. Good. Now, let us get the expectation. The expectation, what do we do? Sam, let us get the expectation together. Unmute yourself, Sam or team. Sam or team. Unmute, work out together. So Sam, what we are going to do, we are going to multiply 0.2 times -2. What do we have?
We have negative 0.4.
Negative 0.4. The -1 times 0.1.
We got negative 0.1.
Negative 0.1. 0 times 0.3.
This is obvious 0. Any number multiplied by 0 is 0.
1 times 0.2, Sam.
0.5. 5. You get a 5.
Wait. 1 times 0.2, Sam. You have to be steady, my friend.
You get 0.2.
0.2. 2 times 0.2.
0.4.
0.4. Now let us add negative 0.4 plus negative 0.1 plus 0 plus 0.2 plus 0.4. What do you get?
You get a 0.1.
You get 0.1. Thank you so much, Sam. I think Sam has nailed it. We get 0.1. Oh, sorry about that. Let me bring it back. And that marks the end of today's discussion. Key takeaways include the meaning of probability. It is key. Types of events. Okay. Mutually exclusive, independent, exhaustive, conditional. Then the probability theorem. There's a video that there are more resources I've shared on your student account. Take note of those resources, videos, and workings. And of course, I may not go into the probability tree because I know you did it in senior 4 and senior 6. So you can go back to your notes of senior 4 to pick up the probability tree. That I'll not do it here, but there are resources on the probability tree shared on your student account. Next on Thursday, shall be talking about the binomial, Poisson, and normal distributions. I think we shall be done with the distributions on Thursday. So let me wish you all the best. We meet on Thursday.